Hey folks, welcome out there. Thursday, and we are here live today on Mathline. We want you to give us a call. What are we going to do? We're going to work some math problems out live. And you know what? On the air, nonetheless, help you out, answer some great questions. I'm Ernie Roberts, and I am your host for this afternoon's session of Mathline. Now, real quickly, what do you notice? There's a number that keeps floating along the bottom of the screen, 844-686-2378. That's the magic number. That's what we want to hear from you. Give us a call. We will work some problems live on the air. And hey, you know, we always enjoy it. It makes the show rock when you guys call in, and we don't want to miss out on anything. Again, that number, 844-686-2378. Our last live day for a day, all right? Tomorrow we'll be on specialized segments mode, so you want to get your time and your calls in today to talk to me, okay? And what more can we do to start off? But you got it, problem of the day time. Let's see what we've got there. If a price has a markup of 50%, by what percent must the new price be discounted to return to the original price? And I know some of you are probably saying, Ernie, there are no numbers in that except what? 50%. So my thought is let's put some numbers in it. That's what we can do. But we can also look at the thing in general. All right, so let's look and see where we're going to go on this. All right, so you basically have said, wow, you start out with some sort of a price. Let's call it 1. All right, why not? And what we're going to do is say, what's the, we already know the percent of markup was what? 50%. All right, so we have a change going on here. And I'm going to use just a little bit of a nice little situation here. Because what we said, we started off with this $1, and we've gone up to $1.50 maybe, all right? I'm just using any kind of money. At a base of 1, you've gone up because that's 50% added to it, all right? So if we look at this, what kind of percent is this? What's actually the overall percent? Overall is 150%. Now you say, well, Ernie, what does that have to do with it? Well, let's see if I'm correct on that. Of course we are going to be correct. We aren't, right? Cross multiply. Let's see what we got. So we got n equaling, goodness, 150. So that's the percent that actually you're dealing with. Now, we want to say we're going to start and get back to 1, all right? So this time, the next part is, all right, so you said, wait a minute, what do you mean, Ernie? I mean, we're going to start at $1.50. In other words, where we are, what is the percent, how much discount, what percent to go back to $1, all right? And you said, what's 50%? Disagree. When we cross multiply there, we did end up with 150%, which meant we increased as 50%. That's what we were looking at. So here's what we're going to think. This time we're going to start at how about it? $1.50, all right? That's where we started. But we've got to go back to where? We've got to go back to $1. So how much do we have to decrease by? This time, we're going to decrease by that 50 cents. So the question is, how much percent is it? In other words, we're going to keep $1. That means we're going to keep $1 out of $1.50, all right? So we're going to look at the other side of it as being what's the actual decrease that got to us there and see where we're going. Now remember, we increased by 50%. This is not going to give us 50%. I can tell you right off the bat. You can tell that too. So let's see what it does do for us, all right? Because this was kind of an interesting Facebook. Many of you just kind of looked at it, I think, and said, don't know if I'm happy about that one. Well, we challenge you occasionally. And this one was really some challenge going on. So let's cross multiply and see what's going to happen here. I'm going to get, looks like, decimal 1/50, 1.5, 1 5/10, goodness, 1.5, you get it. Equals, let's cross multiply. And looks like we're going to have a 50 over there. Now keep in mind, we're going to find this is going to be our percent of decrease, because how much did we lose? Going back to $1, we lost 50 cents, all right? That's the decrease. So again, let's do some dividing. By the way, I guess I need an n right there. And let's do some dividing. Let's go to the calculator on this one, all right? So we don't spend too much time on this. And then I'm going to throw some numbers actually in there. I said you could have tossed some numbers. I made that hint on Facebook right before going on the air tonight for some others who might be motivated to check it out. Well, there it is. It's 33, and it goes on and on and on. So you say, well, Ernie, what does that mean? That means a repeating decimal. And I think we had some of our folks on Facebook that got the 33, and they put 3/10, and someone else did 33, and then someone else put 333. And the truth of the matter is, I think it's because you can't get a bar over the top, all right? That's the problem on those when you're trying to run an answer. Now, you say, how does that translate, Ernie? How's that going to make it work for us here? Because that is percent. That is our percent, all right? So what it's going to be is 33 and a third percent. So in other words, you raised it by half the price that you had to start with. You raised it to get up to that 1.50. You decreased it by 1/3. All right, but you wound up where? Back at the $1, okay? Because when you lost that 50, you wind up at 1. So that's a real interesting problem. It's a real interesting problem. And it basically goes back to the fact that we had a 3/2 relationship here. And honestly, what would be the result? What we have left, this is what we have, and what we would have left over would be 2/3. But what is 1 minus that 2/3? You know, it's kind of, that's what's going on there. Then you would take 1 minus 2/3, you get 1/3. And that's where we are right here, which is 33 and a third percent. A little bit of thinking going on there. And some of you are going like, whoa, that was just for being numbers? Well, or lack of numbers, that was pretty intense. So again, if you put a number in, maybe you put in, let's say 20 to start with, and you went up 50%, you'd have 30. It'd be 30 over 20, all right? Come back over here, you would talk about, well, I start now at 30. And I'm going to come back to that original price. So you'll put the 20, excuse me, you'll put where you started from, and then you work from there. Or, again, say how much you lost. In that case, would be $10. So you'd be 10 over 30, which gives us, yes, 33 and a third percent. So some good thinking out there. Mark and Margie, good job on it there, all right? Y'all were getting it on there, 33.333, and I think you said, Ernie, I need to find those 3 dots. You could repeat it on out like that. But good job, ladies and gentlemen. And keep coming to us on that Facebook, all right? We've got it going. Speaking of Facebook, let's go ahead and give it a plug here, because sometimes I forget about it. Like us, love us, and by all means, share us. www.facebook.com/Mathline online. We try to give something there that can make you think a little bit, innovative in some ways, and also sometimes going like, how'd that happen, all right? I think some of you are going like, whoa, we went up 50%, and then we come back down 33%, and a third percent, we're back where we started. That's pretty cool. Also, don't forget about us on YouTube, where we've got some good things going on. Subscribe to www.youtube.com/Mathline, and we're going to be doing, where you see some of our specialized segment shows in their entirety, or you can just clip through how many you want, or whatever parts you want to look at. But the good thing on that is, they're there. If you miss us on a Friday or on a holiday or something like that, then we've got it going. By the way, we are going to be looking at a specialized segment tomorrow, just in case you're wondering, because tomorrow is Friday. And aren't we all excited? Many of you are on fall break now. Even more of you are going to be on fall break next week. We are still going to be around next week, by the way, Monday, Tuesday, Wednesday. We're going to be here for 3 days. Then we're going to take Thursday off. We're going to have a new show on Friday, though, for you, a new specialized segment. And on the Monday following, it's Columbus Day. So we get a little holiday there too. So we're going to be on a little hiatus. So today, my point being, give us calls, all right? Today's the day you get to talk to us, but we will be back live again on next Tuesday. But strike now. No time better than the present. So give us a call, all right? I hear my phone ringing, and we want to hear more phones ringing, all right? Give our operators some good fun today, and they're spending their time with us. 844-686-2378. And I understand we do have a caller waiting. I thought I heard some phones ringing. Now let's get some more phones ringing, all right? That number again, 844-686-2378. And welcome to Mathline this afternoon. Who am I talking with?
You were talking with Peyton.
Hey, Peyton, good to have you back with us again. I always enjoy hearing from you. You got some good problems usually for us to look at. So what can we do for you this afternoon?
Find the measures of the acute angles of a 3, 4, 5 right triangle to the nearest degree.
Woo! All right. Boy, that sounds like some trig type things. Let me borrow Curious George. Let's draw a right triangle, you said, right? Correct? I mean, oh, no pun, total pun intended. I might as well say that. Let's see. I am going to go for, let's see if I can get this to fit in here. Come on, George. Let's go out here. Because you said 3, 4, 5, right? So
yes.
I'm going to try to create the nice looking proportions that we have here. And then that means it's a right triangle, and I hope this will all, I think it's going to all fit on the page. Good. And this is a trig problem. It really is. Now, folks, we're going to say this is like maybe 3 feet, 3 inches, 3 centimeters, 3 meters. It really doesn't matter. We're going to have a 4 that goes right here. It's a little bit longer than that is. So let's put, maybe we'll put meters on it, okay? Representative. And then you said 5, right?
Yes.
Okay, and it did say it was a right triangle. And some of you may say, well, how did you know it was a right triangle, Ernie? Remember, our good old Pythagorean theorem says that if we take 3 squared plus 4 squared, well, the question is, does it work? Let's go ahead and look real quick. 3 squared plus 4 squared equal to 5 squared. Pythagorean theorem, a squared, b squared, c squared, on the connecting with the a's and b's squared, putting those squares together, adding them, and do you get the same thing? Well, let's check. We get 9, we get 16, we get 25. I'm good to go. So we know that makes a right triangle. So that part checks out. So now, Peyton, what's the question again? We're looking for what? The angle measures?
The acute angles.
The acute angles. All right. Well, I got a right angle. I know it's 90, correct? So let's call this X. I love X. And somebody said, well, what about the other one? Well, I guess we can call it Y. Yeah, it goes together pretty well. So what we're going to do, because looking at that, I don't see that it's a 30, 60, 90. And the reason I'm going to say I know it's not a 30, 60, 90 is that I don't have a halving relationship between the leg and hypotenuse, and that would force this to be a crazy radical anyway, all right? So 3 and 6 would tell me, oh, 30, 60, 90, easy. But 3 and 5 tell me it's going to be maybe a little bit larger than, by the way, this would have been the 30 and this would have been the 60. Everybody remember that? Why? And Peyton, I'll go back and refresh memory here. This is the smallest angle because it's opposite the shortest side. So 3 is shorter than 4, certainly shorter than 5. So we know that our little angle I'm finding here is going to be the smallest of these 3 angles. We have to add up to 180, folks. So just a little quick check and estimating. Gary Petco's on the show with me. I get back in that estimation mode, and I like it. Okay, I like that we do that thing. And it helps us see what kind of problem is going, what kind of answer to our problem is going to look sensible and reasonable. So let's go for it. It's trig. It's either going to be sine, cosine, or tangent. By the way, folks, we got one more trig show tomorrow for you on specialized segments. Some of you are going like, oh, well, we've been watching that. And hopefully you've been remembering, you probably start thinking, oh, I think we can use one of those sine, cosine, or tangent functions here. Actually, you can use any of them because we've got 3 sides at our beck and call. So let's talk about it. Let's look at it from the standpoint of sine X, okay? I'm going to start with the sine. Now, Peyton, I have a good old friend named Chief SOHCAHTOA. You may have heard me speak of him if you've been watching these specialized segments, but if you haven't, it's okay. But SOHCAHTOA says that the sine is equal to, and some people are going, where'd you get that SOHCAHTOA? Let me put it up here. You didn't realize you're going to get a whole deal spiel here, but this is how we're going to work it out. So means sine is the opposite leg over the hypotenuse. It's just a nice little shortcut formation for helping us to remember. Cosine, guess what? Cosine is the adjacent leg, or the adjacent side, as we call it, adjacent leg actually, over the hypotenuse. Hypotenuse is always the longest segment, so that's our 5. And then we got TOA, which is T for tangent, equals opposite leg, which means we're going to go across there, over adjacent. Now, I chose to use sine, so that goes back to the first part of Chief SOHCAHTOA here, all right? So let's look at it. What's going to happen? And by the way, folks, you're going to need to get your nice little old trusty graphing or scientific calculator at least. And some of these scientific calculators work a little bit differently, so that's why I really like having the graphing calculator here to really spell it out on our screen what we're going to get. But just hang on just a second. We'll get there in just a second. So here we are. Sine, opposite, would be 3. You see that, Peyton? Go across the picture. And you got the 3. Now, hypotenuse, I said, is the longest side. So we're going to pop in the 5 right there. Now, all of a sudden, you say, well, that's great. We got 2 numbers, so how do we get to X? That is the magic moment. That's why we're going to go to the calculator. Let me clear it. Now, let's check it out where we're going to go. Dear friends, we are going to go to our sine, cosine, and tangent buttons. If you'll notice, I'm playing there with a cursor. There's the SIN, there's the COS, there's the TAN. If you're on a big screen at home, you can say, wow, those are pretty letters and all. If you're not on a big screen at home, you may have to get close with a magnifying glass or something, but it's there. They're right there through the center. Now, also, even harder to see is there's a little thing at the top right above there in blue, light blue on mine. It may be a different color on yours. It's called sine with a -1. Peyton, you see that on my screen there? See where I'm pointing? Sine inverse.
Yes.
We call that sine inverse. And then there's a cosine inverse if I were doing cosine, but since I'm not doing cosine, we're not going to worry about it. And the tangent, -1, or tan inverse. So in playing that out, what we're going to do, I need, the reason we're going to look at those blue, and by the way, notice there's a blue key. I love color coordinating things, but there's a blue key, we're going to hit it. It says second, and all of a sudden you see this arrow kind of going into crazy in the cursor here. So now we're going to go hit the sine button, and there's our friend, sine -1. Do you see what I got there, my friend? See where we are?
Yes.
All right, now, what we're going to do, we're going to take that 3 and that 5. We're going to put it divided by. And that's it. Oh, we got to press enter. We'll figure out what it actually is. It's going to give us the degrees. And there we have it. And I'm going to round it to the nearest degree, because that's kind of rambles on, as you know. There's a lot of decimal places, aren't there, Peyton? So we're going to take it to the closest degree, which is going to be approximately 37 degrees, okay? Pretty straightforward. Now, I mentioned what would happen if we'd done cosine or tangent, all right? And folks, while I'm going through that, go ahead and give us some calls, all right? I'm going to keep Peyton as long as I can go through a few points here. But we want to hear from you also, so don't please feel intimidated. Please go ahead and give us a call if you've got some questions and problems for us to do this afternoon. So if I did cosine, you say, well, what would happen there? All right. First of all, let me go back to where I am on the calculator. I'm thinking COS, right? So I'm going to be using the cosine button, I guarantee you that. But let's go back to our right triangle here. They're doing a good job up in the booth getting me back and forth. I'm kind of wearing them out a little today. And adjacent leg is this little guy here. This is the 4. All right, my friends out there. So it's going to be the adjacent. Remember, we're going to talk about ka in the SOHCAHTOA. So C is for cosine. A is for adjacent. So watch where adjacent is. That's the 5 that comes out of the X angle there. That's the side of the angle. And then we go back to the hypotenuse again. So we're at 4/5. Now, folks, you say, well, that's different, Ernie. Well, it is, but it's a different function. So let's test it out. Let's go to second on the calculator. Let's go second, and we'll do cosine this time. And we should get cosine inverse. Cosine, as you say, -1 up there, but it's an inverse function. And let's put a 4 divided by 5. Oh, my goodness, what are we going to get? Y'all bet it's going to be 37 degrees, or once again, real close to it? It's the exact same thing. So it's another way to get to your final answer. Once again, we're going to take that and allow X to be approximately 37 degrees. Now, rather than go through it for another function, for the tan function, let's go back to our picture here again. We're going to round it off there to 37 degrees, which is the same thing we got here. Same thing we got here. If you had done the tangent, could you have done tangent? Of course you could. You would be opposite, which would be 3, adjacent, which is 4, and you'd plunk it in the calculator on that inverse button and see what happens. Now, I'm going to make one important warning here on the calculator. It's great to use it. And let's go back one more step here. Before you do what we did, since we're looking for angles, we need to go to our mode. And down the line, here we go. Follow my cursor. Normal's fine, isn't that wonderful? Float, and here's the bump right here. We've got a radian or a degree. I'm going to be honest with you. Many times when you get a calculator, especially if you borrow it from someone, the radian may be bumped on, okay? You've got to make sure you've got that degree. So you say, Ernie, how do we get there? Well, we cursor down, go to the right, and press enter. And that will keep your degree there, because otherwise you're getting a different kind of measure, and they really come out rather funky depending on what you're actually looking for, what your degrees are there, okay? So again, let's go back to our problem here. That just want to be a little note there. Now, if this is 37, Peyton, all you got to do is subtract that 37 from 90, and you'll have your y up there. That part's easy. And actually, the first part's easy. If you just remember to go to that inverse button on your calculator there. And like I said, scientific calculators have the inverse button also. By the way, what are our degrees here? Let's subtract from 90. I like 53. Now, was that more than you bargained for? Probably so. But did it work for you? Make sense?
Yes.
We good? Thank you. Thank you for calling again there. And hey, have a good weekend. And I hope we'll hear from you again next week, all right? So folks,
Thank you very much for your help.
Hey, you're quite welcome, Peyton. Boy, such a polite young man. I appreciate that. So a couple of weeks ago, we had a gentleman who gave us a call at the very end of the show. And to tell you what, he brought in some things. And if you can take, yeah, thank you, I'll take me out. And he asked, could you do some subtraction of rational fraction situations, some rational numbers? And I told him, I said, well, we can. Rob, I appreciate you leaving that with us, and I'm sorry we're just now getting around to it. We've had a pretty busy week and been planning to get to this, and it looks like today's a good time. And first of all, I'll just start off with just good old subtraction. We got 7, and we're going to try to take 3 3/5 away. Again, I like to take these creatures into vertical form when we got to do regrouping or borrowing, as we say. And right now, dear friends, what we have there is 0/5, and we've got 3/5 underneath it. So you can't take 3 from nothing. Sorry, you go in the hole, it goes weird, all right? So what we're going to do in this problem, we are going to go over here and say, okay, 7, we're going to take 1 away from you. What happens when we take that 1 away from the 7? We're left with 6, obviously, okay? But what's going to happen here? We're going to take that 1 and we're going to shred it into 5 strips because, hey, that's what it says. We want fifths. So 1 is equal to 5/5. So we're going to add a 5 right up there to the top. And that gives me 6 5/5, and now I'm ready to subtract 3 3/5. And again, very straightforward, pretty easy. Now we can subtract. Hey, I've got 2/5. When I subtract 5 minus the 3, here we go. We're going to end up with 3 2/5. So that's kind of the tricky moment when we have to regroup and we have nothing to regroup with. Sometimes you have to regroup when that fraction that may be attached to the 7 is still smaller. Make sure you got common denominators before you go there, all right? Now, let's take a look at this next problem because I went ahead and added a negative situation because I wasn't quite sure what exactly how much we wanted to get for Rob, but we're going to go here. And I'm going to do the same thing. I'm going to go vertical on us here. Although you can work at horizontal, it's fine. But I want to subtract. And this is like adding a negative type thing. In other words, we're going to see that in just a minute here, all right? Because I'm saying I'm going to subtract a negative 4/5 here in just a second. Common denominator time. So let's see. We'll keep the 7. We'll keep the 6. We'll keep the minus. Over here, common denominator is 10. Why did I say 10? Because 5 goes into 10 evenly. So that's a good news. Works this really well. Didn't change the 10 here. Don't change the 7. Keep it along. Just stay where it is. 5 goes into 10 and we multiply by 2. 2 times, let me go back here. I'm sorry. 5. We end up with an 8 there. Got my little pen off a little bit. And hey, we can subtract this one. No need to regroup. So I'm going to get 1 and, how about it, 1/10. Okay? Now, what about my next situation here? Subtracting a negative. Basically, what our rule is, we're going to add the opposite. So over here, it was like saying 7 4/5 plus negative 6 7/10. We could have gone there. Although since it all worked out nicely, just do it like you normally do. But on this one, we need to fix it. So we're going to take adding the opposite. So we're going to have 2 3/5. I'm sorry, 2 2/3. Where did I get 3/5? Woo! And we're going to have 4/5 there. We are going to get a common denominator. That's a 2/3 there, my friends. They're still with us here. So we're going to pick up, the 2 is going to stay put. We're going to put a 15 here. And we're going to put a 15 over here. And we had 3, so we need to put a 5 through there because 3 times 5 gets it. So how about it? Let's do 10. We're going to work this one horizontally, as you can probably tell. How about it? 5 goes in there, 3. We got 12. And I'm looking at all of a sudden it's just a simple addition, right? So what's happened is you worry about your signs, but the fraction work is still the same. Get a common denominator and decide, are you going to subtract them or are you going to add them? In this case, we're going to add. I see, wow, 22 over 15. Let's bump that up to 3, and how about, I think, 7 left over? 15ths. That'll work for us there. So there you go, Rob. I hope that gave you a few little examples of working with those subtracting of rational numbers. Signs are important, and they make the things work. Hey, thank you all, speaking of working, for being with us today. We are doing trig tomorrow on specialized segments. Thank you for tuning in today. It's been great to have you with us. Thank you for tuning all week. Peyton, thank you for calling again. And you know what? We're going to see you all again live next week, and we'll see you tomorrow on specialized segments.